Hi friends, I am Malathesh Akkur with experience of 19 years in the field of physics and electronics. My hobbies are conducting electronic projects and the robotics classes from the students for the school kids to the postgraduates. Welcome to the world of neural pruning. Neural pruning will help you a lot to learn the concepts in a better way and enhance your performance in the various competitive examinations. Electronics is defined as the branch of engineering that deals with the study of behavior of electron in gases, vacuum and semiconductors. After the invention of the semiconductors, the size of the electronic devices and the electronic components has reduced drastically. Hence, the components of the electronic devices also miniaturized. For example, at home, we are using radio, television, refrigerator, washing machine, digital clock and cameras and lot more. Not only this, aeroplanes, helicopters and cars and the ships, all these will have the electronic devices. And the robotics is one of the major evolving branch nowadays, which is also the subset of the physics. It includes all the fields like electronics, computer science, mechanics, automobiles and all these things will integrate and so on. The evolution of the robotics has come basically from how a human is going to understand the physical world and giving the response to that. For example, a human has so many sensors and the central processing unit and the actuators. For example, we have the eyes, ears, skin. So these are called the sensors. And the brain, which is the central processing unit, which will receive all the information from these sensors, take the decision and give the instructions to the actuators. The actuators are what? The hands, legs and so on. In the same way, a robot consists of the sensors, controllers and actuators. The example for the sensors are what? LDR, light dependent register, which identifies the light, and thermistor will identify the temperature, and the LED will gives out the light for the sensor. So these are some of the examples for the sensors. For example, the ultrasonic sensor will identify the distance of an object by sending a signal and will calculate the how much time it takes to receive it. So these are all the example for the sensors. These sensors output will be in the form of electrical way, that is nothing but the current or the voltage. The controller will receive these signals, the electrical signals, and apply the rules depending on the applications, and take the decisions and give the direction to what? The actuators. The actuators are the wheels, DC motors, stepper motors and like kind. You have seen one of the important device, electronic device like the computer. Mobile also can be called as a computer because the computer, what are the basic components of the computer? Should have the input device, should have the output device, and the processor should be there and the memory should be there. A mobile will have all these things because it has the input device, that is keypad or touch screen. It has the output device, that is again the screen or the speaker. It has the memory, hence the mobile also a computer. Computer will understand only the binary language. The binary language in the form of what? Is in the form of zeros and ones, where 0 is one voltage level and 1 is another voltage level. So what we call them as high voltage and low voltage. So it is left to the designer to have the voltage level as 5 volts, 10 volts, 0 volts and so on. Most popularly used voltage levels are about 5 volts and 0 volts. There are two types of logic in digital electronics or in digital systems. That is positive logic and negative logic. What is positive logic? The higher voltage is taken as logic 1 and the lower voltage is taken as logic 0. The negative logic is the vice versa of this. In most of the applications, we use what? The positive logic. The different computer languages are there. We classify them as what? The high level language and low level language. So examples for the high level languages are, as you know, C, C++, Java, and all these are what? The high level languages. The low level languages are the assembly language and the machine language. Again, the machine language is what? In the form of ones and zeros. Basically, the machine or the computer will understand only the binary language. But it is very difficult to write the codes in binary language. And it is very difficult to remember for the human beings. Therefore, high level languages like C, C++ are going to be used. So the instructions in C, C++ and all will be like English like instructions. These are going to be converted into machine language by the softwares called what? The assemblers, interpreters and the compilers. Today we discuss the important topic in electronics as what? The electronic devices and the digital circuits. In this chapter, we are going to study the semiconductors, diodes and its applications, transistors, logic gates and related concepts. Now let's go to the classroom to learn all these concepts. Dear students, now let us discuss some of the important topics on the JEE Advanced on the topic electronic devices and digital circuits. The question number 1 is, which is the reverse biased diode? All of you know what is the forward bias and reverse bias. So usually in most of the textbook and most of the teachers also will say, what is forward bias means when the P type is connected to positive and N type is connected to negative, the diode is said to be forward bias. But in most of the applications, real-time applications, the diode is not going to be used to connect to the battery always. So it will be connected in various ways in a circuitry. Actual meaning of the forward bias and reverse bias is what? If the P type is connected to the higher potential and the N type is connected to the lower potential, then we say a particular diode is what? In the forward bias condition. Now let us see the potential at the P type and N type of the each diode in different options. In option 1, P type is connected to the 5 volts and N type is connected to the ground, that is 0 potential. In option 2, P type is connected to minus 20 volts and N type is connected to minus 10 volts. In option 3, P type is connected to plus 15 volts and N type is connected to plus 10 volts. And in option 4, P type is connected to 10 volts, that is plus 10 volts, and N type is connected to minus 5 volts. Before going to the concept, let us see a diode. Say for example, this is the P type and N type, this P type, this is the N type. If it is connected like this, easily we understand it is forward biased. That is, the P type is connected to positive or the higher potential and N type is connected to the negative. If the connections are like this, say for example, this is 2 volts and this is 3 volts. Whether diode is forward bias or reverse bias, in such cases we have to identify the potential at the P type and N type. So this potential at the P type is what? 2 volts. Potential at the N type is what? 3 volts. Of course, this is plus 2 volts, this is minus 2 volts. Which is higher potential? 3 volts is the higher potential. It is nothing but the P type is connected to the lower potential and N type is connected to the higher potential. Hence, the PN junction or the diode is under reverse bias condition. If it is like 12 volts and 3 volts, of course, this is the forward bias. So such concepts are very important to identify whether the diode is forward bias or reverse bias. So now let us see the diode is forward bias or reverse bias in case of the option 1. The P type is connected to 5 volts and N type is connected to 0. Is nothing